This session is particularly designed to understand a very important concept in trusses, and that is identification of zero force member. Now the first question arises that what is a zero force member? So let me tell you that when we design a truss, sometime we put some additional member which are actually not the load bearing member. But what happens when there are some instability occurs in the truss? For example, the truss is primarily designed, suppose we are designing a planar truss and somehow the loads are not in a plane and the loads are out of plane. In that time, these zero force member become the loading member and give stability to your truss. So the topic of the day is basically going to focus on how can we identify a zero force member in our truss, and once we identify the zero force member, then what to do to solve the problem of our truss. So now let's begin with a simple example. Here I am showing a picture. You can see here that there is a picture of a truss where there are 1, 2, 3, 4, 5 joints. There are two supports, one support A which is on the vertical wall, another support C which is on the horizontal plane. Joint C is a roller joint, however joint A is a pin joint. Now I am not going to explain you the zero force member, but first I will ask you to let's start the problem to solve the problem. So when you will try to solve the problem, we know that there are one basic rule we generally follow in the truss is that we have to start from a joint where maximum 2 unknown. Because why we search a joint where we have 2 unknown? Because we are going to start the problem with the equilibrium of any of the joint, and we know that in case of a joint the forces are concurrent and the planar, and we are having only two equations. One is the equation for the horizontal force balance, another is the equation of the vertical force balance. So in this case, if you will start your problem with a joint where you should have a maximum 2 unknown, and if you will see here that what is the case here. If I'll start with joint D, there will be 3 unknowns. If I'll get the reaction at point C, so one reaction and there will be 1, 2, 3, 4 unknowns. So I cannot start from here also. If I'll see joint F, there are 1, 2, 3, 4 unknowns. If I will calculate the reaction at point A, I know that it's a pin joint, so there will be 2 reactions, one horizontal and one vertical. So again there will be 1, 2, 3, 4, 5 unknowns. So in this case, except the joint B and joint E, I can identify that I will not be able to find any single joint from where I can start solving my truss. So if you are not aware about the zero force member, and if you will try to solve the problem, you will have such problems, so that you will not be start your solution. So now let's try to understand the concept of zero force member, and for that I will request to first write the equilibrium of joint B. So when I will write the equilibrium of joint B, I know that there are only two members. One member is going along BC, another member is going along BA. So here I am showing the equilibrium or the free body diagram of my joint B, and I know there are two forces, one force acting along horizontal direction. This is my horizontal X direction and this is my vertical direction, and this is my positive X, this is my positive Y. I know that there are two forces, both are perpendicular to each other because this angle is already given to us. Then when I will write the equation for the horizontal force balance, I know that there is only one horizontal force, this is force BC, and another vertical case there is again one unknown, one force member. So from solving the mathematical equation, I am able to identify that these two members will not going to bear any load, and there will not be any load in these two members. So this is a case where we are having these two members as zero force member. Now let's again try to find the equilibrium of joint E. So here, if we want to state something, we can state that if there are two members only and members only and perpendicular to each other, both will be zero force member. So I can state one rule that if two members only and both the members are perpendicular, then in that case both the member will be zero force member. I am saying that there are only two members, there is no any other force. Suppose a force was acting here, in that case this member will not be, these two members will not be a zero force member, because when you will write the equation the effect of force will come and these two members will become load bearing member. But here these two members are zero force member. So now in the first case we have defined that two members perpendicular to zero force member. So now the question arises, if I am going to consider the joint T, here I know that the two members are not perpendicular. That means these members will be load bearing member or no? Let's see. So now this is the free body diagram of joint E, and I can see here that in case of joint E there will be two members. One member is going along this direction, another member is going vertically downward. So now let's first decide my horizontal and vertical axis. One is the x direction positive, one is y direction positive. When I will write the vertical force balance, this is the equation for basically vertical force balance. So I know that both the forces are going in the downward direction. So if EF cos component cos theta negative sign, then FED again it's a downward direction, so minus FED will be 0. When I will write the horizontal force balance, I know that there is only one force horizontally which will be the component of EF sine theta. So now when I will write the second equation, I will be able to understand that in this equation there are two quantities. Either the theta will be 0 or the force will be 0. But I know that physically there is a theta, two members are having a physical angle, so the theta is not 0. That means definitely the force will be 0. So here I know that when this force will be 0, when I will put the value in this force, again the second force will also be 0. So I can conclude from the second joint that the force EF as well as the force ED both will be 0. So now I have to modify my first rule, where I was saying that if the two members are perpendicular, then the zero force member. But now I can say that the two members, and irrespective of the angle, if the members are only two and there is no any other external force acting, no external force or joint, then the member or the two member will be zero force member. So now in my equation I have now identified that there are four members which are not actually the load bearing member, and these four members are this 1, 2, 3 and 4. So now before solving the problem I can directly remove these members, and then I will be having a simplified truss which will be easy for me to solve. So here you can see that I am showing that now this is the modified truss member, where this member and as well as these two members have been removed, and now I am having only 1, 2, 3, 4, 5 members and a single load. So now the problem has simplified and it is very easy to solve this problem. However, I am not solving this problem. First I am going to discuss the concept of zero force member. Now let's again take a second problem and try to identify that what is happening here. So now this is my second problem. Here you can see that there is a truss, and there are 1, 2, 3, 4, 5, 6, 7 members. AB, BC, CD, DE and EA are the, similarly AD and AC are the 7 members. Member BC and member CA are perpendicular to each other, and this is an angle phi between member AD and the collinear members BC, CD and DE. Joint A is a roller joint and joint E is a pin joint, and I am having a force of 10 kN acting in the horizontal leftward direction at point B. So now again, first I want to see the first rule. Is there any member which is having only two members without any force? No. If I am going to see the joint B, there are two members, but I am having a third additional force, so these two members will not be zero force member. Similarly, I am having two member at joint E, but there is a support, so again it will not be a zero force member. So now here I will request to make the free body diagram of joint C. So here I am showing the free body diagram of joint C. You can see here that this is my C member. There will be a force along direction CB. another force will be along CD, and third force will be along CA. So I am showing three forces, FCA, AC, FBC and FCD. And if I will write the equation for the horizontal and vertical force balance, first I have to consider my two reference axes. Suppose this is my X and Y axis. So here will be my horizontal axis and here will be my vertical axis. But at this point I would like to add that it is not always essential to consider your reference axes in the horizontal and vertical direction. You can consider your reference axis with any angular position. Here, if I will see carefully, I know that my two members are perpendicular. So if I will consider my reference axis in this way, suppose this is my X axis and this is my Y axis. So it will not affect my final result, but my equation will be simple. If I will consider these two reference axes, I have to find these angles and then I can write the equation for horizontal and vertical force balance. However, if I will consider these two are my reference axis, then this is my positive X and this is my positive Y. And now I am not going to use this axis. In that case, my equations will be simple. So now you see, if I want to write the equation for the X force balance, I'm not saying now it's a horizontal, I'm saying it's a X direction force balance, and these two reference axes are again the orthogonal to each other. So if I will write the force balance along X direction, FCD is going along positive X and FBC is going along negative X. So I'm writing that FCD minus FBC will be 0. When I will write the vertical force balance, or I should say the positive Y force balance, I know that this force is going in negative Y direction and no any other force which will be contributing in this direction. So there will be only one force, FAC, which will be 0. If you will consider this kind of quadrant as a reference, here also you will get the same answer, but you have to find first angles and then finally you will get the same answer. So from the solution of this joint, free body diagram of joint C, I can conclude that force FAC is 0 force member. However, I am not able to get answer of these two forces, but I know that these two forces will be equal to each other. So what is the conclusion here? Here we can say that if there are collinear member, with a side branch and the branch is perpendicular, so the perpendicular branch will be a 0 force member. So I can define one rule that when we are having collinear members with a side branch and the angle of the side branch is perpendicular, the perpendicular side branch will be my 0 force member. So here in this case, this branch AC will not going to bear any load and it will be my 0 force member. Now here I can conclude that these are the two collinear member, member BC and member CD are collinear with a side branch. The same situation is here, but here the branch is not perpendicular. I am having side branch collinear member CD and DE and with a side branch DA. What do you think? Will this be a 0 force member or not? Let's see again. So here I am showing the free body diagram of my joint D. So joint D having two force, one is going along DC, one is going along DE and one third force is going along DA. So here is my next free body diagram, and here also I would like to consider my quadrant with a different orientation. So this is my positive X and this is my positive Y direction. So when I am going to make this vertical axis and this vertical, or I should say this is positive Y and this is positive X, and when I will write the force balance equation, I know that when I will going to balance the plus X direction force or X direction force, FD will be in the positive direction, however FCD is in negative X. Similarly the X horizontal X component of force AD, so force AD cos phi will also be in the negative X direction, because my references are now this way, this is X and this is Y. So this will be my negative X and this will be my negative Y. So horizontal or plus X direction force will be balanced. So this is my force balance in X direction. When I will write the force balance along the y direction, I know that these two forces are not going to contribute along this direction. The only this component of force AD is going to contribute. So here you can see that FAD sine phi will be 0. This is the similar condition which we have seen in our previous case. Here also either the force will be 0 or the angle will be 0. But I know that physically the angle is there, so force, only the condition satisfied when the force will be 0. So from here I know that the FAD will be 0. When I will put FAD here, again the same FCD and FDE, two force will be there and which will be going to balance each other. However, I am not able to tell about the magnitude. So here also I have to modify my previous rule where I was saying that the two collinear member with a side branch, with a perpendicular side branch, then the side branch will be a zero force member. But I have seen here that irrespective of the angle, if the two members are collinear and there is only single side branch, please remember there is only single side branch. Suppose there would have a force, in that case there will not be any zero force member. But if there is only two collinear member with a side branch, then irrespective of your angle, the third branch, the side branch, will be a no load member or zero force member. So now there are only two rules. One rule says that I can now conclude that there will be only two rules. One rule, any joint with two members, maybe in this position, maybe in this position, irrespective of the angle between the two members, if there is only two member and there is no any other force, the two member will be zero force member. So these two will be my zero force member. The second rule says that if there are two collinear members and there is a side branch, maybe the collinear member in this way and the side branch, maybe the collinear member in this way and side branch is going with a certain angle phi, the side branch will always be 0. So now with these two rules, there is only two rules for the zero force member. Otherwise, whenever you are having the forces, the members is going to bear the load. So now again here, when I have observed that these two members are not going to bear any force, so I can reduce my truss with a very simple format. And now I am having, this is my simple truss which is having only three members, because these two members have now removed, these two members are zero force member, and this is my truss which I can solve with a very few steps. So now let's try to solve one problem. So here is the problem, and in the problem we can see that there are many members, and what has been asked, find the forces in members CD and JC. So if I will see that's A, B, C, D. So this is one member where I have to find the force D, E, E, F, F, G, G, H, H, I, I, J, J, K, L, M. So I have to find the force in these two members. So these are the two members where I have to find the forces. So one of the way, you should directly start solving the problem. You have to identify a joint. Here in this case, if you will calculate the reaction, you can start your problem either from point G or point A. And when you will solve the problem subsequently, you will find that okay, these members are zero force member. Let me tell you, it is not always essential that you have to identify the zero force member in the beginning. If you will solve the problem in a proper way, these members will ultimately come as zero force member. But what happens, your labor will be more. You have to solve more and more joint. But if you are able to identify the zero force member in the beginning, then your labor will be reduced and you can solve the problem in few steps. So it also saves your time when you are solving a problem in your examinations. If you will having more members, more joints, then you have to spend more time. So now let's solve this problem without any delay. So here also the first job, whenever you are having a problem of truss, now you should make some thumb rules. The first thumb rule should be, you have to first see carefully, is there any zero force member? If you observe any zero force member, before solving the problem, you should remove those zero force member. So in my case, now I know there are two rules. First rule says that two members alone. Second rule says if there are two members with a side branch, the side branch will be zero. So here if I will see carefully, I can see that the joint H. In the joint H, the member IH and HG are collinear and my HF is a side branch. However, when I will see the joint F, here I will not be able to say, because now there will be two collinear member but the two side branch. So when you have two side branch, you cannot conclude that these two side branch will be 0. But if you have only one side branch, then only you can say the side branch will be 0. So if I'll consider my joint H, I know that at joint H there will be member IH and HG, and the third member is your HF. So I know that from my rule that the side branch will be 0, so I can remove this side branch. Similarly, if I'll go and I'll see my joint L, I will be able to see that from AL and LK the LB will be a 0 force member, so I can remove this member, I can remove this member. So now I am showing a picture where I am showing all the members, and as now we have identified few members are 0 force member, I am going to erase those members. First I have observed that this is my 0 force member. So now if I will remove my, let this is my A, B, C, D, E, F, G, this was H, I, J, K and L. So now I have removed this member. As I will remove this member, I can immediately identify that again there is a similar condition where I am having FE and FG are the collinear member and this FI is a side branch. So as I will remove this, I can identify that okay, this will also be a 0 force member, because now when I will remove this member will become a 0 force member because these two are the collinear. So now I am going to remove this second member also. Now my truss has reduced to this level. Similarly, when I will see the other side, I can remove the L. As I will remove the L, I know that now this BK has become a 0 force member. So this will be a 0 force member. As I will remove the BK, I know that my KC will be a 0 force member, because now these are the collinear member and this is a perpendicular branch. So this will be 0. When I will remove KC, the CJ will also become a 0 force member. However, when I will consider the joint I know that there are 4 members. Now there are no the single side branch. When I will consider joint I, let's see the free body diagram of joint I. Here at joint I, one force is there and one branch is there. So the joint I will not be a 0 force member, means this is not a 0 force member. As this is not a 0 force member, this will not be a 0 force member. So now ultimately when I will remove all the 0 force member, my truss will look like this way. So all the other members, which were the member, one member were here, one member were here, there were 2 members, all the members now have removed, and I have a simple problem where I am having only 1 2 3 4 5 6 7 8 members, 1 2 3 4 5 6 7 8 9 members, and 1 2 3 4 5 6 joints. So now I can solve the problem, and as I know that joint A is a pin joint and joint G is a roller joint, so I am taking 2 reaction at G is vertically upward, and at this is pin joint, there will be 2 reaction, but I know that there is no any other horizontal force, so my horizontal member will be 0, so this will be 0. When I will balance the vertical forces will say that these 2 will be equal to the 10 plus 8 18, and now I am going to take moment at point A. So when I will take the moment at point A, this 10 will be multiplied with the total distance 6, because this distance are 2 2 2 2 2. So this is my distance, which is 6, this is my distance 2, and this is my distance 4. So now when I will calculate the moment at point A, I will be able to calculate the value of reaction GY, which is coming out 10.33. Here you can see that I have put positive sign for the moment of force 10 and moment because of the force 8. However, GY is having negative because I am considering clockwise as positive moment and anti-clockwise as negative moment. This is my positive and this is my negative. So 10 will have a positive rotation, 8 will also create a positive rotation when the point will be pin. However, the point G will try to rotate the whole body in the counterclockwise direction. We can identify if I am going to put a pin and I am ignoring all the force, this force will try to rotate the body in the counterclockwise direction. So it is going to have a negative or counterclockwise moment effect. So when I will solve the problem, I am getting that the GY is coming out 10.33 Newton. When I will put this value in my previous equation, which is vertical force balance equation, I will be able to see the AY is coming out 7.67 Newton. Now I have this value which is coming out 7.67, GY is your 10.33, and now I can solve. I have to find the forces in member CD. However, now I am not able to see the point C or D, but I know that all the members are collinear members. So whatever force I am going to calculate in this single member, this force will be similar or equivalent to all the members. So I am going to take the equilibrium of joint A. And when I am solving the horizontal and vertical equation, here also I am taking both the forces are going away from the node. Away from the node means these are the of tensile nature. However, at this point I don't know if my answer will be negative. I have to change the direction, which we have already seen in our previous video. So now solve this joint, and when I am solving this joint, I am getting that force AD is coming out minus 15.33. Basically AD is this A and D. So this AD is coming out minus 15.33, and I know that basically this AD is equal to AB, BC, CD and AD. All are nothing but a collinear member, and the forces for all the member will be 15.33, but I have removed the negative sign and I am saying the nature of the force will be compressive. Similarly, I have already calculated that the force in the JC member, the JC member is already gone. So this is my zero force member, this is my zero force, zero force, zero force. Here also it is zero force member. So now the whatever force I am calculating in AD will be for the member AB, BC and CD. So now I will at the end I am just going to tell you give the solution or the clarity of the two problem which can be which are the important problem. Here is the one problem. I am not going to solve the problem, only I am going to explain that how you can identify the zero force member. So can you tell me which members will be the zero force member here? So we have to find carefully that there are two rules. First rule says that if there is only two member, there are only two members, the two member will be zero irrespective of the angle. And the second rule says that if there are two collinear member with a side branch, irrespective of the angle, the side branch will be a zero force member. So here these two will be my zero force member, here the side branch will be the zero force member. So in this picture, if I will see carefully, joint B is having only two members and there is no any other external force, so these two members is going to be zero force member. Similarly, if I will see the joint D, there also there are CD and DE are the only two members, there is no other external force. Agar if there would be any additional force, then these two members will not be zero force member, but in my question there is no any other force, so these two will also be the zero force member. Now if I will see the joint F, joint F is having two collinear member with one side branch, but there is a force. As there is a force, if I am going to make the free body diagram of joint F, I know that there are two member, one is FE, another is FGF, third is going another FJ, and the fourth is the downward force. So as I am having a downward force, these members will not be zero. However, when I will see the joint H, at joint H, these are the two collinear member and this is a side branch, so this will be zero. Now this is zero, so I can remove this joint, but when I will go and I will see the joint I, this IJ is again a side branch. So let's make the free body diagram of joint I. There are two collinear member, one is IA, another one is IC, but there is a force at this point, so member IG will not be a zero force member. This is a side branch, but there is a force acting here, so now the rule doesn't follow, and I can the member IG will not be a zero force member. So only these four will be zero force member, as well as your member H will be zero force member. So if I simplify my truss and I'll make a simplified diagram of my truss, that diagram will be look like there will be only, this is my pin joint, this is my roller joint, there is a member, there is a member, there is a member which is having a vertical force here, and there will be one member which is having vertical force here. So this is the simplified diagram of my truss after removing the zero force member. Let's see the last example. In this example, it's clearly observed that there are 1 and 2 and 3 and 4 and 5 joint and external horizontal force acting at point F, and if you have to solve this problem, at the first instant you can see that this is the side branch. But if you will start your problem solving this joint, you will not able to say that this is my zero force member. But if you will see this joint, you can say that this is the two collinear member with a side branch. So this side branch will not going to exist, and when you will remove this joint and you will going to make the truss again, the truss will be only these members, one joint, second joint, and there will be a fourth. So here we have seen how we can calculate the zero force member and what to do when we find the zero force member in our truss. Thank you.